with that, I'll skip the presentation, and basically what I'm going to tell or show that was in the presentation. So if you guys are okay or if you allow, can you just come in front? Those who are interested, I can like start with the demo. So even if I don't show the presentation, they are not gonna miss anything because the same thing is there. So it will be just a walkthrough what we are going to do. Okay. So if it works, if it works, if it not, I'll just walk through. चलता है? No, I just wanted to point as well if there are some photos. Yeah. Okay. याच्यामध्ये तीनच चारच डायग्राम आहेत. My name is Suyog. There is one more Suyog, and we are like good buddies in Mumbai. So he will be my guinea pig for all the jokes. So I'll be cracking jokes on him. So please bear with that. So so most of you have not made antennas. That I can say. Home brewers are in minority. Maybe they don't have instruments to test whether it's working or not, so they are getting discouraged. So that can be one of the reason. So see, there are few things in home brewing as well. There are like lot of what do you call, in Hindi we call it a pantha or like sects. Some people believe like everything should be in home brew. Some people are like everything should be professional grade. But there are few things in which something is better than nothing. So like nano VNA, this is not a professional grade VNA or a spectrum analyzer, but this is good to have because even if you home brew a what do you call, a frequency generator, that is your oscillator, or HWR meter or something like that, you need to have a reference value. Like if your that calibration value is accurate, then rest everything home brewing you can build on it, and that will be a pretty accurate on that. So this presentation is done in a very haste because my main focus was on like showing you on practicalities, but let's go with the convention. So the next slide. So basically, why we need two instruments? One is spectrum analyzer and VNA. So any one of you know what spectrum analyzer does apart from the frequency? Anyone? Yes. So you know everything. So you can tell. Yes, but yes. Yes. So, yes. So, anyone know what is like time domain or frequency domain? Like, should I touch that topic or it will get too technical? That I wanted to know. Like, okay, I'll give you a brief. So, everyone knows oscilloscope. If not, everyone knows ECG. सब पिक्चर में देखा है. फ्लैट लाइन, हीरो मर गया, फिर माँ या फिर उसकी वाइफ कुछ भगवान को मन्नत मानती है, समथिंग समथिंग समथिंग, आदमी जिंदा होता है. होता है पिक्चर में सब होता है. Something like that. So when same thing happens with electronic engineer, ये मर गया, he replaced the component and it starts working. But in human you can't do that. So that's why I didn't go for MBBS, I went for engineering. So jokes apart, and thank God people are not dying because of me. But there are a lot of loss to my company because I'm burning a lot of things. So what you see on oscilloscope or ECG, that's your time domain graph. So a voltage or amplitude versus time. But if in a frequency domain, when we convert the same signal, you will get amplitude versus frequency. So if there is a sine wave, if there is a like a very high grade or industrial grade oscillator you have, the output will be a pure sine wave. There won't be anything else. Like if it's 100 hertz, it will get pure 100 hertz. Now you take a home brewed circuit, like anything, like you make a FM transmitter or AM transmitter and घर पे ही बनाया, like proper, like with whatever the amateur grade things you have, a hobbyist grade, not even amateur grade, a hobbyist grade you have, and you connect same thing to a spectrum analyzer, you will see that 100 is there. 100 will be, so let's assume it's at 1 watt. Then you have something At 200 hertz, you will get some curve which will be at lower power and lower power. So you will see like a bounce kind of thing going down, 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 down. So it will be something like this, like this, like this, like this, like this, like this. It will be going on. So, like if you are importing something, a WPC, so they ask for a WPC license. Like, do you have a permission from WPC? Lot of hams who are importing, they are in that loop. WPC is saying for amateur radio, you don't need a WPC permission or NOC, whereas the custom said, we don't know. हमारे पास गैजेट नहीं है, हमारे पास notification नहीं है. You go to WPC, you go to your local WPC office, they say ham radio things they don't need. We have already cleared that. So you are in cash 22. So now why does WPC ask this kind of things? Because like if you are importing any wireless devices from outside, not only ham radio related, your Wi-Fi router, wireless drone transmitters, video transmitters, do they conform to these signal norms? Like you have, let's say you have a Wi-Fi router, you got it from Alibaba, AliExpress, company is unknown, nothing is unknown, it should be transmitting on 2.4 gigahertz, but you see you're switching it on. Though how many of you are like Instagram? You might be on Instagram, a young guy, no? So there is a viral video going on, like some guy is turning on his microwave and the opposite building lights are switching off. That is because that microwave is transmitting on 2.4 gigahertz and it's not in its channel. The spurious signals are here and there. And what that company who has made automated things, what they have done might be a signal is there, a signal is present on 2.4 gigahertz at that frequency, switch it on. Again some pulse is coming, switch it off. So it's not doing any encryption or anything like that, just on and off, it's happening. So WPC wants to make sure that whatever devices are coming in India, if they say I'm transmitting on X frequency, it is transmitting on X frequency and nothing else is not there. So how do they do it? So itna ram kahani bolne ka matlab kya hai? How do they do it is the main thing, and what I'm going to tell you. So there are these instruments, like in a spectrum analyzer, when you there are two ways to test. Now please bear with me because my company makes 4G and 5G modules. So there are a lot of testing is to be done from our customers for the end certification. So I do help them and been part of such testing. So I may get some into two technical things. Like there are two kind of such kind of EMI, EMC testings or radiation testings. One is conductive and radiative. So in the radiative is like there is an antenna connected to a device and the antenna is connected to your transceiver, and then we test. Your instrument, test instrument also has an antenna, and your DUT also has an antenna, and then you test it. Another thing is we put an attenuator and directly it's connected to a cable. So there are no other radiation losses and you just check the pure theoretical maxima and minima. So all these devices are connected to a spectrum analyzer and we see what are the harmonics. When we say harmonics in ham radio, the first thing comes bacche. But where actually we are seeing the fundamental harmonics which creates lot of issues. How many of you know, all of your rigs are made in Japan, like ICOM, Yaesu, Kenwood. So you know that Japan is a heaven for ham radio guys. Everyone is under that assumption, right? Like cheap ham radio, like radios are cheap, APRS network is superb, their repeater network is superb, so that's on. Do you know in Japan, it's very difficult to homebrew? Anyone had this idea? So in Japan, if you homebrew something, that's need to be get inspected by local WPC, whatever the WPC equivalence is there. They will test it in a lab, they will certify, and then only you can come on air. So when we say that, grass is always greener on other side. Yes, any question? No, I thought no, behind you. So we say like Japanese hams, they have access to cheap radios and cheap superb network of repeaters and APRS network. You can go on Twitter and check my handle. I had a discussion with Japanese ham and he had put this like in India. it's very easy to homebrew. So there is no restriction over here. You transmit whatever you want. The WPC, as a typical disclaimer, he says whatever you want to do it in a ham frequency. You are not allowed to go. But how will you make sure that you are in ham frequency? If you go to the upper edge of our 2 meter, like 146 or something, can you assure that you are not going into central railway, like railways frequency or some local police frequency, or in case of Mumbai fire brigade is there, and some other things I don't want to name. Uh, those are there. If you go down, you will come into airband. You may go into, like, that's the biggest thing. Sir, you can correct me if I'm wrong. If you go on airband, what will happen? Like, पूरा जिंदगी में से आपका बर्बाद हो जाएगा. So we have a pilot, ex-pilot sitting here, so he can vouch for that. Like, never ever transmit on airband, or never even listen on airband. We are not supposed to do that. Like, there can be very severe ramifications. Airband is a frequency where pilots communicate with the airport. Yeah, exactly. So we are on camera, so that's why I said don't listen. Mhm. True, true, true. Secrecy of communication. Yeah, yes. True, true. Yes, yes, yes. Yes? So that is ADSB. So the B in the last stands for broadcast. So anything which is broadcast and which is not encrypted, you can receive. It's not point to point and you are coming as a man in the middle. The ADSB in the last B stands for broadcast. So it's. Mhm. Mhm. Yes. 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 So so is it okay or not okay? Like, it's a gray area, right? Hmm. 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 Okay. So as long as you are like keeping your head down and walking in straight line, nothing will happen. So coming back to this thing, so ये तो WPC का डर है ही, but when actually WPC, if they do a surveillance, like during Operation Sindoor, everyone was telling me कि like WPC was highly active and like monitoring all these things, or they do have their annual drives, and you were caught, like you're transmitting, you're saying I'm transmitting on 80 meter, but that signal is also coming, the harmonics is coming on 40 meters and creating QRM, you will go. So ये सब डराने का बात ये है कि why we have to do these things. So then other things what we have to do is, spectrum analyzer does basically two things. What we want, like Ham's point of view, is like what are the harmonics, like you give a signal, how, what is the integrity of that signal, that when I'm saying it's 100 hertz, whether it's 100 hertz, like when you buy what do you call, anything from supermarket or pre-packed thing, it has written that it's 1 kg, and then they have written plus minus 1 gram, 2 gram, something like that. So that is legal. The same way, the spectrum analyzer, the basic things it will show you, like if you are saying this frequency, that if it is a proper tone, then it should be a pure 100 hertz. But if it is a audio, then when you are transmitting an audio, it will have lot of frequency components, because our oral range is like from 10 hertz to 8 kilohertz. So as I speak in the carrier, there will be this voice component as well. So there will be lot of ups and downs. So that you will come to know. We also use this for reverse engineering. So before coming to the reverse engineering, I'll tell what the second part. Second part, it says the power. So now using a spectrum analyzer or VNA or anything, you need to have a proper calibration. So without any calibration, it's very difficult to find the accurate this thing. What's the accurate value? So it's like how to say, uh, you have a weighing scale at your home, and in some scale there is a feature that if you stand, it will show your weight, and again if you press one button, tear button, it will, and you get down, it will show negative. Like suppose my weight is 100 kg, and I put a tear, I click on tear and get down, it will show minus 100, and then I put something else, it like 10 kg thing, it will show minus 90. So we are getting, we know that weight is 10 kg, but it's showing minus 90 because it's calibrated like for 0 show minus 100, and for 10 show minus 90. So that's the calibration part in a basic way. So you need to calibrate your VNA, your spectrum analyzer. So if you do it, calibrate it properly, and you are transmitting on 5 watts, it will show that you are transmitting on 5 watt. But now any instrument can't take 5 watt or multiple watts as an input, it will get burned down. So if we put an attenuator, so whatever is your power, like you know this DUT is like 10 watt device, and I want to test it, you will put an appropriate 10 dB, 20 dB or 100 dB attenuator, and you will test it. So these are the two things which we use for signal integrity, that whether I am having harmonics or not. We use a spectrum analyzer for that, which is its basic functionality. Like घड़ी में आप क्या करते हो, time देखते हो, फिर आप उसके बाद क्या आता है, it smart watch, it can track these, that, or olden Casio shows you time, date and everything, or alarm. Added features. Basic क्या करेगा, it will show you two things: frequency, components, and your power, like कितना power आ रहा है. So these are the two things. Spectrum analyzer, I am not getting into that thing because ठीक है, ये दो करने के बाद क्या? The actual interesting part is in a VNA. So we can go to next. So see, this graph I was talking. This should be my original this thing, but then it can go up and down as per this thing. Next. So VNA, just go next. Let me check. Next. Okay, come down to that second last photo. Yeah, that's it. So in presentation, what I have written is like, अरे ये भी चला गया. What I have written is about what you can do with this VNA. This VNA in the sense, this is the amateur grade VNA of what can a VNA do, and why VNA is like a multi-tool of a telecom engineer. VNA kind of thing आपके घर में भी use हुआ है. Who has a fiber optic internet at their home? 1, 2, 3, like Geo fiber or local cable. Most of you. So this VNA आपके घर में use हुआ है. When the installation was happening, those guys came, they put a red laser, then they did something, then like okay, एक घंटे में आपका internet चालू हो जाएगा. और whenever you have a like disruptions, like sir fiber optic कट गया है. So see, I have now two ways to give this presentation. Like this is a topic 1, topic 2, topic 3, or should I use this thread and start from here? Like take this example, how they detect where the fiber optic is broken, and then correlate with this. You guys tell me, because actually this is first time I'm giving talk in front of hams. I usually give a talk in in a professional setting or in an engineering college to a student. So either I'm on this end or on that end, like basic end or like high end. So, and usually if it is in a college setting, it's always interactive because students are like eager to know everything and they want everything hands-on. So I need some feedback from you guys. Like, okay. वो तो आना ही है, वो तो इधर आके मैं बताने वाला ही हूँ. So in that case everyone can come here and we can start the demo. So I'll just no, the device is here, I'll be switching it on. But you guys will be coming here and seeing. Okay. No, but then I would have taken one and like make him do the things. So let him record. We can have a hands-on, and like, or I can come down there and then show you how it is. So coming to like, rather than going in a theory part, topic 1, this thing, topic 2, this thing, let's be interactive. Like take this example, your fiber, you don't have internet, you are angry. Where internet nahi chal raha hai. Someone sitting at your home wants to see you on live YouTube, what you'll do? They will come, they will check first, sir, backend में तो सब सही दिख रहा है, आपका नहीं चल रहा है. That's the same answer everyone gets. After that, you again call him, 2-3 गाली दोगे, आएगा. First thing what he does is like he puts a red laser. This is a green laser, but he will put a red laser and check something. He will just get out of your home and check something, because till that yellow OFC, you can see the red dot. So it should not be visible anywhere. Where there is a broken, the cable is broken, the OFC is broken, you get a leakage and you see that thing. So that's the, where yellow cable hai, udhar to easy hai. After that, you know, there is a black cable. Udhar to dikhega nahi. So how do they do it? So there is something known as TDR, time domain reflectometry. And what we will be doing is like frequency domain reflectometry, FDR. So in the TDR, what they do is they will bring some device, a small meter kind of thing, they will connect to OFC, they will press this thing, the light will go, and where there is a break, it will reflect back and come down. So they know the attenuation of the cable, because they know a cable kaun sa hai, like we have cable RG58, LMR 400 and all those things. OFC ka bhi similar thing hai. So they know the model number, it's already pre-programmed, or they will put the parameters, and then he will do this thing. So the machine knows what is my loss. Jane ka loss, aane ka loss we consider as same. So we divide it by 2. So now I get the jane ka loss. So ek gaya kitna, matlab I started now, my stopwatch has started now and I'm sending the pulse, and the pulse came back. So basically what the radar and sonar works, the similar principle it will do. And then we find out ki like 10 meters from this point, or in case of undersea cables, like 100 kilometers from this point or 500 kilometers from this point, the OFC is broken. And then they go there, repair it, aapka internet chalu ho jata hai. So same thing happens here. You have an excellent working antenna, you had an excellent QA. So let's talk about the 2 meter, then we'll come to HF. Everything is going fine. आप सो गए, you went QRT, next day you came, HWR meter is high. Usually we don't put HWR meter on 2 meters, usual hams, but we put it on HF. So you don't care, like let's assume you don't have a HWR meter on this thing, a 2 meter, and you're giving a shout, no one is coming, you're not able to get a tail of your repeater. Ho kya raha hai? You go up, you see your antenna is okay, nothing happened. कल रात को बारिश हुआ था, उतना ही है. You see there is no water leak, nothing, all okay. What happened? So now those who are staying in a bungalow, they are like, itna cable length is like hardly 10 meter to 20 meter. You can remove it and test manually. People who are staying in like Mumbai kind of thing, high-rise building, you are staying on first floor, your terrace is on 16th floor, 14th floor, you can't remove whole antenna. First and foremost, आपने झगड़ा सोसाइटी के साथ झगड़ा करके एंटीना लगाया, बराबर. एक तो आप झगड़ा करके सब कर रहे हो और उसमें वापस आके निकाल रहे हो, तो बोलेंगे अरे निकाल दिया है ना, अभी मत लगाओ. So you don't want to do that, right? So what you will do, you will take a VNA. What we did with the fiber optic, you will do the same thing. You will first calibrate this VNA. I'll come to that point later, because that calibration you have to do for any kind of measurements. So you do the calibration of this VNA, connect your antenna fit to that, select your cable type, let's assume it's RG58, and let's hit. Like what you'll do, you'll measure a length. It will show you, like let's say your cable run is 20 meter, it's showing you 15 meters. So that means ऊपर से 5 मीटर नीचे या फिर इधर से 15 मीटर आपका केबल में कुछ प्रॉब्लम है. You go there, you say there is a kink or something broken, or the insulation is corroded and water seep in. You get that. So जो घर पे OFC वाला का था, as I said, like VNA was already in your home, but that was a vector for the optics. This is a vector for your RF. So this is how you will test. So what things you can do with VNA? VNA can do lot of things, but for VNA, the beauty of VNA is like we need only 3 or 4 parameters. One is your frequency, One is your return power, that is a standing wave ratio, and yeah, that's it. Transmission power and receiving power both are both comes under VSWR, so both take care of it, and the frequency. Using only this two or three, how you measure parameters, you can get everything about your transmission line and your antenna. So this VNA is of 2 port, but in industry you get 8 port, 16 port and multiple port VNAs, and those will cost you like 3 crore and above. So you can do lot of things. Now this one, this VNA I guess goes till some 1 gigahertz something, 1 point something something. But in industry you will get till 10 gigahertz, like DC to 10. This is like some kilohertz to some hertz to 1 gigahertz something like that. And I guess the Radio Hub was selling for 3 gigahertz version as well. So that was the costlier one. So basically VNA will measure, VNA will inject some frequency at some power in your feed line or antenna, and depending on that you can get pura janam kundli of your antenna, your transmission line. So using this, what you can do, you can find out how your matching impedance is of your feed line. Then again after feed line, it will also you can also measure what is the impedance of your antenna. When we say the antenna tuning is there, so there are a lot of thoughts about antenna tuning and everything. So basically some way of calling antenna tuning is like antenna resonance. That antenna should be resonant at X frequency. That specially comes in the HF. That my antenna is resonant on 80 meter or 40 meter or 20 meter. That's the one part. Second thing is matching. There are like inbuilt tuners in your rig that doesn't match your antenna, that doesn't make your antenna resonant, but they match the antenna impedance and your rig's output. So from your radio point of view, your impedance is 50 ohms. आगे क्या हो रहा है? Radio is happy, I am getting SWR less than 1.5, but your antenna is not resonance. So these are the two things how you want to test. The VNA will give you both the things, whether your antenna is resonant or you're just what do you call impedance is mismatch, or it's just matching this thing. So that thing one you can do. Then antenna bandwidth you can find, antenna efficiency you can find from this. You can also if you know the cable length, this can also tell you what type of cable it is. So you can also feel like if someone is selling you this is a LMR 400 and I'm selling it you for dirt cheap, you can actually go and check whether it's actually LMR 400 or not. It will give you the attenuation and you can find it out. So these are the main things a regular ham can do with a VNA. So now like I'll show you the demo. So anyone interested, you can come here and we can start with that. No. Agilent is like they starts from 16 lakhs. Okay, we have a Fox that is like 16 lakhs and it goes till 3 gigahertz.
Let's do a couple of questions. Anyone has any questions? Can ask questions and then we'll do the demo.
Yeah, no problem.
Because otherwise, once you see the demo, you could leave.
Any question, anything. Even professional grade questions. That
We have to take to the lab or
no. It has inbuilt calibration. See, actually original calibration for any RF related tool should be done with some industrial grade instrumentation. Like let's say you want everything in this needs two things. One is a frequency generator which needs to be accurate, and then detector at what power and what frequency it is receiving. So if you have done this calibration on some original equipment and then you keep doing it on, there will be some drift, but for our amateur grade that drift is acceptable. Yes. So if I like, yes sir. This one.
Is kept in the video recording mode. Then the recording.
Yes, but I don't have to. We will have to put a tool in that. Yes. No, my laptop is not connecting.
Whatever the image seen on your laptop screen will be projected, right?
Yes. My laptop has tool, but this is not working, connecting. In this, we'll have to put a tool.
Yes, yes. Even though the video recorder is just video recorder is made, and you can show the image device to the video recorder.
Can do.
So what he's saying is,
I know, I
open
got it.
camera
Yeah.
there,
Yes.
use the same screen for it.
Okay.
It will project on this one.
You can try.
Try like streaming it on this. I think this is the extremely small font. I have an NOV.
I know that. I know that. टाक ना याच्यात टाक ना तोपर्यंत याला इंटरनेट आहे मी केबल काढतो